Hi, this is Mrs. Wiederholt, and welcome to my lesson video on relations and functions. Now let's get started. First, we need to define relation and function. And these are terms that I'm sure you learned in Algebra 1, so this will probably be a review for most of you. A relation is simply a set of ordered pairs. Now let's look at an example. The set of 1, 2, 1, 3, and 1, 4. Those are three sets of ordered pairs, three pairs of ordered pairs. And this little symbol right here means the set of. So right here, if you were to plot this on a graph, it would be 3 points, 3 ordered pairs. That's what a relation is. Now let's define function. A function is a set of ordered pairs in which each x element has only one y element associated with it. Now let's look at an example of a function. Here we have the ordered pairs of 1, 2, 3, 4, and 2, 3. Again, these ordered pairs represent 3 different points. Now, unlike these ordered pairs, these 3 ordered pairs represent a function. Look at the 2 sets of ordered pairs for just a moment. If you need to, pause the video and see if you can tell what the difference is. Why, for example, these 3 ordered pairs are a function and these 3 pairs are not. I'll give you just a moment. Now that you've had time to look at it, let's go over it together. In our definition of a function, it says that each x element, well, here is an x element, this is an x element, and this is an x element. That's what that means, your x coordinates. This x coordinate of 1 has only one output, or only one y element. It's the 2. Now for this x, the x is 3, it only has 4 for an output. Same with 2. It only has 3 for an output, or 3 for the y element. So each input, or each x element, has a unique or different y element. Now let's look over here at the relation. I have an x element of 1, and it has a y element of 2. But if I look here at this ordered pair, it also has an x element of 1. But this time, instead of the y element being a 2, it's a 3. And in this third ordered pair, this x element of 1, again, has a y element of 4. So this 1 is being paired with 3 different y elements. And if it is paired with more than one y element, it cannot be a function. So if we're looking at our 2 examples, we can now know that this set of ordered pairs represents a function, and this set of ordered pairs only represents a relation. Now, I want to ask you another question about this one. Does this set of ordered pairs also represent a relation? And the answer to that is yes, because if you read the definition, a relation is simply a set of ordered pairs. Aren't these just 3 ordered pairs? So, yes, this is not only a relation, but it is also a function, which leads us to this statement right here. All functions are relations, but not all relations are functions. What this means is that anytime you have a set of ordered pairs, you do have a relation. Whether it's a function or not doesn't matter. You do have a relation. However, in order for that relation to be a function, you can only have one. For each x input or x element, you can only have one y element. That's the difference. Now let's move on and see if we can tell by looking at a graph whether our relation is actually a function. When looking at a graph, you can tell if the relation is a function by the vertical line test. If a vertical line crosses the line or curve more than once, then the relation is not a function. However, if the vertical line or if a vertical line crosses the line or curve only once, then the relation is a function. So let's look at some examples of this. If we look at our first curve, or our first graph right here, we see that we have a curve for a line. So let's try the vertical line test. What we're going to do is you just take any vertical line and draw it straight down. How many times did I cross that curve? I only crossed it one time. Now, no matter where I draw this vertical line, I should only cross my graph one time, or cross my curve one time. And if you can see, it's not going to matter where I draw this vertical line. It's only crossing that curve one time. So that means this graph represents a function. Now let's look at our second graph. Now in this graph, we actually kind of have a shape here. We have an ellipse. So let's try our vertical line test. I'm going to pick right here. And look what happened. How many times did I cross my curve? I crossed it twice. That right there tells us we do not have a function. Even if there were other parts of this curve where we only crossed it one time, for example, if I draw a vertical line down at the end, at this end point, yes, I'm only crossing it one time, but everywhere else I'm crossing it twice, crossing that curve twice. All it takes is one time of crossing your curve in two places and you do not have a function. Now let's look at the third graph. Right here we have a straight line. So I'm going to go ahead and I'm going to draw a vertical line. And would you agree that it doesn't matter where I draw my vertical line, I'm only going to cross the straight line one time. So that means, yes, we have a function. Now, you might ask, how do these graphs relate to what we just learned on the page before about ordered pairs? Well, here's how it relates. Let's look at this middle graph, for example. Let's say that this point right here is 0, -1. 0, -1. And this point up here, I don't have my glasses on, so 1, 2, 3, 4, I think it's 5, is 0, 5. I might be off a point. But now watch. Do you see how I have this one x element of 0, and it is paired with two different y elements? That's why this is not a function. If you look at the first graph and the second graph, for every x value that you have, you will have a different y value. So that's how those two relate. Now let's move on and see the different ways that we represent relations and functions. There are multiple ways to represent relations and functions. One way to represent is by a table. And that would look something like this. You would have x, y, and you might over here have -2, -1, 0, 1, 2. And your y coordinates, they could be anything, 3, 4, 5, 6, 7. Now remember, each x and y coordinate represents an ordered pair. So you can tell if this set of values represents a relation or a function. And here I have different x values, so each x value has its own y value, so my table here represents a function. Now let's look at mapping. With mapping, it looks like this. It's two ovals, and in the left oval are your x values, and in the right oval are your y values. Now I can use the exact same ones I want for this example, -2, -1, 0, 1, 2. And over here would be my y values of 3, 4, 5, 6, and 7. Now again, these would be matching ordered pairs. And so that's how you would tell if it's a relation or a function, because this x and this y represent an ordered pair. Now let's look at a set of ordered pairs, which we've already done. That would be, for example, -2, 3, -1, 4, 0, 5, 1, 6, and 2, 7. So that's an example of a set of ordered pairs. And then for a graph, well, we know what that would look like. You have a graph, and you would plot these ordered pairs. I'm just going to do my best here. -2 up 3, -1 up 4, 0, 5, 1, 6, 2, 7. And obviously my points, if I connected the dots, would be a straight line. But anyway, these are the 4 representations that we use to represent relations and functions. Now, I hope this video has helped you understand a little bit more about relations and functions, and I look forward to working with you again. Bye-bye.